So now we're going to look at our third shape. Oops. Okay, our third shape is called trigonal planar. That's when you have 3 bonds and the central atom has no lone pairs. So we're going to be looking at BCl3 as our example. Keep in mind that all of these are covalent, so we're only looking at non-metals. So trigonal planar. We have boron with its 3 electrons, valence electrons. You have chlorine with 7. And this is the way I've taught you to draw it using Lewis structures. But really what happens is these chlorines are going to want to spread out as far away from each other as possible. So it's really going to look more like this. All of the angles between the chlorines are exactly the same. They're all 120. Because remember, 120 times 3 gives you a 360-degree circle. So they're spread out evenly, kind of looks like a triangle. They're also all in one even plane. If you look at this model, you can see that the central atom is boron, all the outside atoms are chlorine. It looks like a triangle. They're all in one plane, like you learned in geometry. So that's why this is called trigonal planar. Now, since all of the outside atoms are chlorine, they have a stronger pull on the electrons than boron, so they're all slightly negative. So each of these bonds are polar. But the molecule itself, all the outside atoms are slightly negative. So since all of them are slightly negative, there's no difference in charge. We would say that this molecule as a whole is nonpolar. Now, if we were to switch out one of these outer electrons, if we were to make this orange, and let's say that this orange atom represents fluorine. You know that fluorine has the strongest attraction for electrons. So now all the electrons are wanting to come over here. Even though they're still sharing, they're more attracted to this end of the molecule. That would make this molecule polar. But as long as the outside atoms are the same, it's going to be nonpolar. So that's your third shape. That's trigonal planar. The fourth shape is similar to trigonal planar in that it involves 3 bonds, but the difference is that now the central atom has a lone pair. This shape is called pyramidal. So the example I'm going to give you is PF3. And remember, anytime the central atom has a lone pair, it's always polar. So just like bent, pyramidal shapes are always polar. So let's look at that molecule PF3. We're talking about the pyramidal shape. Phosphorus is in the middle. Fluorines are on the outside. All right, and that's the way we draw it using the Lewis structures. What it's really going to look like is you've got this lone pair on top, and these fluorines are just trying to get as far away from the lone pair and as far away from each other as possible. So rather than, it's still going to look like a triangle, but rather than being all in one even plane like we saw with trigonal planar, since they're all bending away from that lone pair, it looks more like a pyramid. Now it's not all in one even plane. It looks more three-dimensional. So this is called the pyramidal shape. Keep in mind that whenever you have a stick without an atom on the end, that represents a lone pair. And once again, since there is a lone pair on the central atom, this shape is always polar. And just to show you that using our charges, phosphorus would be slightly positive in this case. All of your fluorines would be slightly negative, because fluorine is the most electronegative atom. So now you have one side of the molecule that's slightly positive, one side that's slightly negative. That creates polarity. So that is your fourth shape. And now we're going to talk about the very last shape, and that is tetrahedral. Tetrahedral is whenever you have 4 bonds. And since, for the sake of what we're going to learn, 4 bonds is kind of the capacity for an atom, we're not going to have any lone pairs on the central atom. So the example I'm going to give you is CH4, and for its polarity, you'll notice it's the same as trigonal planar and linear. It's going to be polar if the outside atoms are different, non-polar if the outside atoms are the same. I'll show you that example. Tetrahedral. And we've got CH4. So that's the way you would draw it using a Lewis structure. It looks more like this. I don't know that that's too different, but if you look at the model, it's hard for me to draw in 3D. This is how it looks. So all the bond angles are exactly the same. No matter how I turn this molecule, it always looks the same. Anytime you have 4 bonds, we're going to call that tetrahedral. Now in this case, all of the outside atoms are slightly positive because they're all hydrogen. The carbon would be slightly negative. So once again, we see polar bonds, but the molecule as a whole is nonpolar. If we were to switch out one of these atoms with something else, now it would be polar. Now you have a different atom with a different electronegativity that's going to cause the electrons to all flow in a certain direction. So that's the end of the slides as far as I want you to get today, but I am going to switch over to the chart that I put in your packet. And we're going to fill this chart out together. And this is just a summary of everything that I just taught you. So the first shape we're going to learn, or the first shape we're going to recap, is linear. Remember, for linear, you're going to have either 1 or 2 bonds, and you're going to have 0 lone pairs on the central atom, if there is even a central atom. For the polarity, it's going to be nonpolar if the outside atoms are the same. So if you have, I'm just going to use AB as my example. So if you have 2 A's bonded together, that's nonpolar. If you have A, B, that's 2 different atoms, that's going to be polar. And then if you have a molecule like we saw with CO2, where the outside atoms are the same, that will be nonpolar. Notice that these are double bonds in this example. All right, for our next shape, we have bent. For bent, you'll have 2 bonds, and for the number of lone pairs, it's going to be 1 or 2. Keep in mind, when we're talking about lone pairs, we're specifying how many are on the central atom. We don't care how many lone pairs are on the outside atoms, just the central atom. For bent, because there's a lone pair on the central atom, it's always polar. And then for this, we'll just put lone pairs on A and make B's our outside atoms. The next shape is trigonal planar. That's when you have 3 bonds, 0 lone pairs on the central atom. And for the polarity, it's just like linear, nonpolar, if the outside atoms are the same. So we'll just have those outside atoms as far away from each other as possible. The next shape is pyramidal. That's when you have 3 bonds, but the central atom has 1 lone pair. Just like bent, since there's a lone pair on the central atom, they are always polar. And that's going to look like this. So I should probably recap. This is polar, this is nonpolar, this is polar. All right, so back to our last shape, tetrahedral. 4 bonds, no lone pairs on the central atom. The polarity is just like linear and trigonal planar. It's going to be nonpolar if the outside atoms are the same. And for the Lewis structure, I'll give you 2 examples. In this example, all the outside atoms are the same, so that's going to be nonpolar. In this example, one of the outside atoms is different, so that will be polar. All right, so that is your lesson on molecular geometry. Please let me know if you have any questions.